First of all, for the introduction of the halogens are a group in a periodic table consisting of six chemically related elements: fluorine, chlorine, bromine, iodine, and the radioactive elements astatine and tennessine. The term halogen means salt former because these elements will really react with alkaline metal and alkaline earth metals to form halide salts. The halogens all have the general electron configuration of Ns2 and Np5, giving them 7 valence electrons. They are 1 electron short of having the full outer of S and P sublevel, which make them very reactive. For the background of the halogen group, in 1811, the German chemist Johann Schweiger proposed that the name halogen, meaning salt producer, from Hals, salt, and genin to baguette, placed the name chlorine, which had been proposed by the English chemist Humphrey Davy. Davy's name for the element prevailed. However, in 1826, the Swedish chemist Jans Jacob Berzelius proposed the term halogen for the elements fluorine, chlorine, and iodine, which produce a sea salt-like substance when they form a compound with an alkaline metal.
You guys might be wondering what elements are in the halogen family. So, in halogen family, we have six elements, which is fluorine, chlorine, bromine, iodine, astatine, and tennessine. So first, we're going to be introducing you guys to fluorine. So for our first halogen family, fluorine. Fluorine is the lightest member of halogen family. At room temperature, its physical state is a pale yellow-green gas with a sharp and pungent odor. As a non-metal gas, it is a poor conductor of electricity. For its chemical behavior and reactivity, it has extreme reactivity because it reacts with almost every other element, including noble gases like xenon and krypton. Other than that, fluorine also has the strongest non-oxidative agent, meaning that it has an incredible ability to pull electrons away from other items. Lastly, for the fluorine common uses, fluorine gas is used for plasma etching in semiconductor manufacturing to create microchips. It is also used in the form of uranium hexafluoride to enrich uranium for nuclear power plants. Lastly, it is used in the synthesis of many pharmaceuticals like Prozac and in PET scans. So for those who are wondering what is PET scans, it is in the picture provided. So that's all for fluorine. For our second halogen family, we have chlorine. Chlorine, positioned in period 3, gives it a larger atomic radius and slightly different physical behavior than fluorine. At room temperature, its physical state is a yellow-green gas. As a non-metallic gas, it is a poor conductor of electricity. For its chemical behavior and reactivity, chlorine is defined by its hunger to fill its outer electron shell to reach a stable octet. It has high reactivity to reach with almost all elements, particularly metals, to form chlorides. For example, sodium chloride and ACl. Chlorine also has a strong oxidizing agent, and when dissolved in water, it forms a mixture of hydrochloric acid and hypochlorous acid that gives chlorine water its disinfecting power. For chlorine, common uses: chlorine used in water treatment to kill bacteria and pathogens, especially in swimming pool. The active ingredient in household bleach for whitening and disinfecting. And lastly, about 20% of all chlorine is used to make polyvinyl chloride (PVC) for pipes, siding, and medical tubing. That's all for chlorine.
For the third family for halogen members, we have bromide. First of all, we need to know bromide is the only non-metal element that exists as a liquid at a room temperature. First, for physical property, we need to know bromide is a reddish brown liquid with a strong irritating odor because bromide vapor are highly reactive with a mucous membrane and respiratory tissue. Exactly evaporates to form a reddish brown film and is a higher corrosive and toxic. On the contact, bromide attack a skin and tissue causing a burn and irritation. For number two, we need to know chemical property for bromide. Bromide is higher reactive to less reactive than chloride and fluoride. Easily form a compound such as a bromide like sodium bromide and it act a oxidation agent. For number three, we need a naturally occurrence for bromide. Bromide does not occur freely in nature because it's highly reactive because it too readily forms stable bromide salt with metal with accumulate in seawater, salt lake, and bright deposit, where it's commonly found and interact industry from a seawater or underground bright. For the lastly, we need to know about using where we can using a bromide. First of all, bromide are many using in various industries such as being using a flame reduction, using a photography, using a medicine, using in the agriculture, and using in the water treatment such as a swimming pool because it's a strong reactive and ability to form a stability compound made a effective, surprising composite, producing light sensitive material, acting as an antiseptic and sedative control pest and disinfected water. That's for bromide. Next, we have iodide, which is iodide is an important halogen element for both human health and industry using. First, we are looking for physical property. Iodine is a dark gray black solid with a metallic luster that readily sublimate into the dark purple vapor. Has a sharp and detailed odor. Has a sparkly solute in the water but solute in alcohol and another organic solvent because its a molecule structure are weak intermolecular force allow for easy sublimation and solubility in organic solvent, while it is not polar, nature limit water solubility and volatile vapor produce in pungent odor. Secondly, for chemical property iodide is reactive but less reactive than fluoride and bromide, readily forming iodide like compounds such as potassium iodide, acting a mild oxidation agent and readily using in a chemical reaction industry process because iodine has large atomic size and lower electronegativity, make it less reactive than a lead halogen. However, its ability to gain electron allow a form stable iodide compound act a mild oxidation agent and be effectively evolving in chemical industry application. For number three, we are looking for natural occurrence. Iodide does not occur freely in nature because it's a higher reactive and readily form stable iodide and iodide compound, which is accumulate in the seawater, seaweed, salt deposit, and soil, same as bromide. For using what we can use for iodide properly is using a healthy medicine for medicine. It's, iodide is using a health as electricity and supplement a proven goiter in a medicine for diagnostic tests such as thyroid imaging and radiography. In the industry for dyes, photography, organic chemical production, in nutrition, and acting a salt preventing division because ability from stable compound react with organic molecule and play an essential role in thyroid function, make effective in application. That's it for iodide.
Next is astatine facts. For the physical properties, sometimes astatine described as probably being a black solid or having a metallic appearance, and the state at room temperature is solid. Secondly, rarity and formation. Acetylene is the rarest element in Earth's class, found in trace amounts from uranium and thorium decay. Less than 50 milligrams is in the top of the class. Thirdly, chemistry and behavior. Chemically, it behaves similarly to iodine, but with some metallic properties. Forms hydrogen acetate and hydroacetic acid, similar to hydrochloric acid. And lastly, uses and potential. Unfortunately, for acetylene, it's extremely rare and limiting uses for its properties. But acetylene 211 shows promise in targeted radiotherapy for cancers like melanoma and prostate cancer.
Thank you, my friend. And now I will explain about the last chemical element from the halogen group, which is tennessine. Tennessine is a synthetic, superheavy, and highly radioactive element that was created in laboratory through a nuclear fusion. It was first created and announced in 2010 and officially recognized by IUPAC, International Union of Pure and Applied Chemistry in 2016. The synthetic occurred at the Joint Institute for Nuclear Research (JINR) in Dubna, Russia, with researchers from Oak Ridge National Laboratory (ORNL) and other U.S. institutions involved. The name was given as a reference to the state of Tennessee from southeast United States. Tennessine has 170 atomic number of proton or electron if it's neutral state. Apart from that, the number of neutron is 177. This is because tennessine, with the atomic mass of 294, is the most stable isotope since there are multiple tennessine with different neutron numbers but unstable. The electron configuration is Rn or radon is 5f14, 6d10, 7s2, and 7p5. And the next part is the conclusion, which is based of all of our analysis about the halogen group. And we believe that our conclusion is the halogen group from the periodic table are very important chemical element for the living being and for the country's economy, even if halogen can be highly toxic in concentrated form, causing severe respiratory, cardiac, and systemic injury, or even death through inhaling or contact. Not only is very crucial for human health, such as creating a toothpaste, and purify the pollute water, such as the picture below, it is also very important in use of industrial and safety benefits, such as creating a light bulb. And we believe that students should learn about the halogen group because it is for their benefit for their future when it comes to learning about chemistry.